All right. Good afternoon, everybody. I'm Peter Vanney. I'm data analyst at the Chelan County Public Utility District, and I'm joined by my fellow data analyst, Natalie Baerlocher, and software engineer, Jessica Blackburn. Our section is the Chelan Chronicles, Seeking Deeper Analytics. And Elaine, if you don't mind going to the next slide. Oh, it actually is Seeq with a Q. And that's the name of the software. So here's the agenda. I'll give a quick explanation of who the Chelan PUD is and where we are, and an overview for our use of Seeq. Then we'll dive into 3 use cases, and then we'll wrap it up and turn it back over to Elaine and PSE. Okay. So the Chelan County Public Utility District, or the Chelan PUD, is a nonprofit, customer-owned utility in central Washington. We are a vertically integrated electric utility. We have our local water, wastewater, and fiber optic internet divisions as well. Chelan County borders the Columbia River, and we have 3 hydroelectric dams with a total nameplate capacity around 2 gigawatts. Our 2 dams on the Columbia are mostly run-of-river, so we don't have much storage. And the third is at the base of Lake Chelan, which is a very popular recreation destination. Fun fact, our Rock Island Dam has both the oldest and the newest powerhouses on the Columbia River. Of our power gen, only about 20% supports our local load. We sell the rest, which allows us to keep local rates low at just over 3 cents per kilowatt hour. We serve about 50,000 residential customers, and at the PUD, we have around 850 FTEs, including trades. So Seeq at the PUD. We purchased our first Seeq licenses in the latter half of 2019 as a way to do more visual analytics on our sensor data. We primarily use OSIsoft's Pi data archive, and Seeq has built-in connectors for Pi as well as other data historians. Within a few days of buying licenses, we were able to start using it for analysis, thanks to their excellent linked video series called Seeq University. At the end of 2019, we also brought in one of their analytics engineers for 2 days of in-person training with a broader audience, including more of our IT and OT staff, hydro engineering, control systems engineers, and senior management. What a time that was, back when you could physically bring people together. Seeq is helping us advance our digital transformation efforts to innovate with data, broaden operational data access and increase visibility, develop and strengthen our data-driven culture, leverage existing investments and systems, and stay flexible with solutions. However, we're not here to talk about a digital transformation roadmap and all that, so we want to stick to some examples. And with that in mind, I'll turn it over to Jessica.
Thank you, Peter. Okay, so for the first use case, I'm going to be reviewing kind of how we approached our GADS event data reconciliation. We had some challenges in front of us at the start of the year. We were asked to automate the process of identifying and reporting our reserve shutdowns for GADS event reporting. In addition, the district wanted to capture a very accurate historical availability, capability, and other metrics, which meant that we needed to identify each outage to the minute. Considerations for this. To capture the historical availability, we needed to know our exact outage times. We were capturing our events, but not the exact times of the events in all cases. Planned work times and the actual work times aren't the same. So our ITOA system that we use captures planned work, but it isn't always a perfect representation of our actual work. Behind every outage, there's a story that needs to be understood, and we were finding that the data alone wasn't enough for us to fully understand that outage event. So what was needed? Well, we needed a way to represent the data from several different sources in one display, something that was easy for people to view. And to understand the story of the event, we needed to gather the right people in the room to discuss those outages. We needed to be able to pull everyone together and go beyond just what the data was telling us. So Seeq became our answer. Like Peter said, we purchased it at the end of 2019, which was a perfect timing for this. It allowed us to import data from several sources. We pulled it all together to help tell the story and present everything in one location for the team to review. So on this slide to the right, you can see in that image, it's a display from Seeq and it shows data from several different sources. The dark blue bar indicates our GADS event that was already entered into the reporting system. The lighter pink bar shows the sensor data from PI, indicating that the outage event was identified. The green bar shows the planned outage from our TOA system, and the dark pink on either side indicate entries from our hydro log. On the next slide, this gives just a little more of a view of the display in Seeq. So on this, we're able to drill into different windows of time and view the individual details associated with each, what they call capsules. In the lower left details section, you can see that we've pulled in data, sensor data from our data historian. We gathered the generator breaker position, the available flag, and the megawatt output from PI. Using that information, we were able to create additional conditions to isolate certain situations, and they have many tools available for this. We have here, if you can see, there's something labeled the identified outage. That's when the breaker is open, available is no. And then we have the reserve shutdown, breakers open and available is yes. But in addition to just looking at that sensor data, we needed to consider the results of the reconciliation process where the team actually determined the exact outage events. They were able to capture the non-reserve shutdowns. We needed to make sure that our reserve shutdown times didn't overlap with the events that they had submitted. So you can see the events that they submitted are here as our GADS events 2020. Our reserve shutdown logic actually includes the times when the breaker is open, available is yes, and then also we don't already have the GADS event entered. So there's a little extra logic there. In the lower right portion of this screen, it provides details associated with the specific conditions that are being met. The data displayed here is customizable depending on the fields available from your external data sources. So these details help us see for this exact example that TOA expects the outage to be for an exciter brush maintenance, that GADS has a maintenance outage or an MO that has been entered, and the hydro log entries support the outage, showing that the unit is being declared unavailable and then available. And you can see all of that in that data below in the lower right section. On the next slide, we have a sample of our reserve shutdowns. This screen shows a 10-day window on one of our units. The dark red bands across the top indicate the unit is in a reserve shutdown event. So you can see there are several of those on this screen. This was very helpful. Actually, just yesterday, we submitted over 600 reserve shutdowns for our Q3 GADS reporting. And we were able to do this without any manual entry, which is huge. On the last slide, it's just a quick overview of our Seeq technology that we used. We used SQL connections and the API to get data in and out of Seeq. We are connecting to our Oracle and SQL Server databases as well as PI. Seeq is able to connect to other data historians, but they aren't limited to PI, but we do use PI, so that's what we're using. I know that was a lot of information, sorry. Raced through it, but we do have a lot more to share, and I'm going to turn it over to Natalie, who just joined us, and she's going to take the next use case.
Thank you, Jessica.
Yep.
So I'll be talking about how I use Seeq to create a performance dashboard for Chelan PUD's fish ladders. So to give a little background, one of our hydro projects, Rock Island, has 3 fish ladders, which fish use to swim upstream to their spawning grounds. In order for the ladders to be effective, the fish need to be attracted to the ladder entrances, and the ladder needs to have sufficient flow to support climbing to the top of the dam. And to be clear, the ladder entrance is below the dam and the exit is above the dam because it's named from the fish's perspective and they're swimming upriver. So there's three main components that we measure to ensure we are adequately assisting adult fish passage. The first is tailwater differential, which is the difference in height between the ladder entrance and the water level downstream of the dam. The second is the depth of water over the entrance gate. And lastly is the depth of water in the diffusion chamber, which is near the ladder exit. And the reason we're measuring this one is because it's easier to measure water depths than it is to measure flow rate. So with engineering equations, we can calculate the flow rate based on the depth of water in that chamber. So one of our core values at Chelan PUD is stewardship, and that implies being good stewards of our community and our resources, but also in this case to our environment. And that's what motivated us to set some internal standards for the bounds of each of these three metrics. So prior to Seeq, we had limited ability to view the raw data. Well, we had the ability to view it and scroll through it and look at historical periods, but we really had limited ability to calculate scorecard metrics with that data. So we didn't really know if we were meeting these targets. And there's a lot of history of different efforts in our organization to try to fix that. But when I started the PUD in March, the process was one of our engineers would every week take the time, export the data to Excel, do these percentage calculations, and then send an email with the updated metrics. And I believe he was only calculating metrics for the left fish ladder and not the middle and the right. So the goal here was to create a dashboard with metrics for all three ladders that updated automatically and free up our engineers' time for more important projects. And so with Seeq, that's what I did. So in this slide, what I have is a screenshot of the Fishway metrics dashboard, which uses the Seeq organizer. What Jessica showed earlier is the analysis functionality, but here in the organizer, it allows you to symbol that analysis into a document that anyone with a Seeq license in our organization can view. So on the left-hand side here are the different documents for each of the ladders, both as a weekly and a monthly report. And the document that I have open is the weekly left fish ladder. Each of these three colored bars is the percentage of time during that week that we operated within the bounds of that metric. I have a horizontal line at 90% because that's our internal operating goal. And then below that is the same information, but in numerical form. This is hooked up directly to our data historian, and every time this page is opened, it automatically updates with the most recent data. We've already had some quick wins with this dashboard. Shortly after I finished developing this, our operations superintendent used it, and he noticed the depth of water over the entrance gate on the middle ladder was consistently underperforming. And when he dug into the issue, he found that our operating system was reporting that we were moving the gate to make appropriate adjustments, but in reality, the gate was stuck in position and not moving. So he was able to get a crew out there and fix the gate, and he otherwise would not have known if it was an issue except by viewing it on this metrics dashboard. And I'll mention that this dashboard is still a work in progress. I think one of the great things about showing people data is that it drives even more questions that can be solved with data. So there's always fun things to work on. But the ranges that I'm showing on this dashboard are primarily for salmon, but other fish species like lamprey have slightly different requirements. And that's why it's showing tailwater differential, which is the blue bar, around 60%, because it's currently lamprey season, so the bounds are slightly different. So right now, one of our control system engineers is working on importing those dynamic bounds into a PI tag, and then I can swap that into this report. And with that, I'll pass it back to you, Peter.
All right, thanks, Natalie. Okay, so I'm going to talk about the development of some soft sensors on our Kaplan blade angle pressure cycles. So here we're defining soft sensors as a signal based on pre-existing sensors used to measure new equipment. So many of our turbines are Kaplan style, which means that the blades can rotate to adjust for a wide range of operating conditions and megawatt outputs. In the top picture on the right, you can see where the blue blade arms meet the hub body and allow for rotation. When we rehabbed a turbine recently, we added pressure sensors on the hydraulic pistons that control the Kaplan blade angles. The lower diagram shows a basic cutaway of the linkages that control the blade angle movement. River water is kept out of the hub by bushing seals, and the movement cycle of the blades is a contributing factor to bushing seal life. So with these new sensors installed, we're more able to accurately track these movement cycles. So mechanical engineering at the PUD asked me to develop a soft sensor that we could use on the other units. So Seeq is my go-to thing for stuff like this. Right, on the next slide, you can see how Seeq makes it fast and easy to visualize data for exploring. To develop the soft sensor, I pulled in relevant signals from the newly rehabbed turbine, C9. On the left, you can see a snapshot of the Seeq workbench and how pressure changes between the push and pull pistons adjust the blades and keep them in the optimal position for the desired megawatt output. Each time the pressure switches from the greater pressure on the open side to greater pressure on the closed side, we count a half cycle. So open, close, open is a full cycle. And you can count that by calculating the pressure difference, the orange line, and counting each time it crosses 0. Or if you only have the blue turbine blade position signal, you could count peaks and valleys in the blade position signal. And that's the goal with the soft sensor. All right, Elaine. And I know I'm running low on time, so I will try to be fast, especially on the math section. So all of our turbines have that blade position signal. So you can count the peaks and valleys there by calculating the derivative. And then you just find when the derivative equals 0. But because of the way our data historian compresses data, a similar calculation is the running difference function, or in Seeq, the running delta. So then with Seeq and these functions, I'm able to visually try out different cutoff thresholds using capsules. So that's what's on the far right there, is the different threshold set to calculate those green capsules on the top of the middle image. Now, the key part here is that those green capsules were developed only using the purple blade position tag. And the fact that they line up with the orange pressure difference cycle is big, and that was the whole goal. Find that right combination of thresholds to mimic the signal in orange, but only using the purple signal. Okay, so then the next slide shows a little bit longer term and how those pressure cycles line up with the blade position cycles. The bottom screenshot shows the blade angle cycle applied to a different turbine. This one is C7. So now we can monitor a factor of bushing seal life without full unit rehabs, because we've developed a signal, blade angle cycles, that captures the same information as the new sensors do. All right, so just to wrap things up here, we're still learning all the uses of Seeq, but here are some of the things that we've done. Identifying conditions and sets of conditions of interest, transform signals, statistical modeling, frequency analysis, like fast Fourier transforms are built in. You can do root cause analysis really easily by leveraging those combinations of conditions. And so here's our endorsement. Seeq's combination of speedy visualizations, powerful built-in formulas, ease of use, and straightforward data connections make it our preferred analytic tool for interacting with time series data. That's all. Thanks.
Oh, thank you so much, Jessica. Thanks. Thank you so much, Jessica, Natalie, Peter, for some great real-life examples of how you've utilized Seeq. And with that, since we're right